All right, today we're going to be talking about unit rate, but with complex fractions. And I don't want you to be concerned because I want you to remember that every fraction, and write this down somewhere, remember it, commit it to memory, every fraction is a division problem. All right, every fraction is a ratio. Every fraction can be turned into a decimal or a whole number with a decimal after it, but every fraction is a division problem. So to find unit rate, we divide, and we blank when we simplified ratios as well. However, it makes our answers for our unit rate different than our answers for ratios. So we divide when we simplified ratios as well. So do you remember what makes those different is that a ratio has the same units. And you could think of those as labels. So they would have the same labels if you're thinking about a word problem. And then those labels cancel out. So if you remember doing conversions, when we converted from like inches to miles, we had to go through that whole process and we got rid of the labels. Those canceled out as well. So when I do that with ratios, that's what happened. The labels cancel out. But when I'm doing rates, rates are going to have two different labels or two different units. And so when we're finished, we actually have a label when we're done. So some acceptable ways to write our answers. We can write our answers, I'll switch colors here, we can write our answers as fractions. We can write them as decimals. We can write them as whole numbers, because sometimes when I do that division problem, I get a whole number. So whole numbers, or I might have a mixed number, meaning a whole number with a fraction. So, for instance, Samantha can read half of a chapter in Harry Potter and the Sorcerer's Stone in 1/6 of an hour. How many chapters can she read per hour? So we still want to go to that last sentence, and we're doing chapters per hour. So that means that we want chapters in the numerator, and we want hours in the denominator. And when we finish, we want to have it for one. I was going to abbreviate there, and then I didn't. For 1 hour. I want to find out for 1 hour. So right now it says she can read half of a chapter in 1/6 of an hour. So the 1/2 will go on top, and the 1/6 will go on the bottom. And I know sometimes that looks scary at first. It's just a division problem. So it's just a fancy way. I can take this and I can write it. I could have also written it as 1/2 divided by 1/6. And we know that we just do keep the first fraction, and I'm going to multiply by the reciprocal. So I'm going to get 6 over 2, which is equal to 3. So that means she can read 3 chapters in 1 hour. I could also have drawn something out. So if you like models, if I'm talking about 1/6 of an hour, cut this in half and then cut it into thirds. So this is 1/6. These are all 1/6, correct? So these are in hours down here. So this is 1 whole hour. So that whole green box there, this whole thing equals 1 hour. So this is 1 hour. Down here, this whole thing is 1 hour. And if I can read a half of a chapter, well, there's 1 whole chapter and there's another half of a chapter. That got me to 2 chapters, 2 1/2, 3. So that's another way I could do it if I wanted to use a model. I could cut this up into 6, because that would be the hours, and then I put 1/2 chapter with each 1/6 of an hour. So every sixth of an hour, I can read a half of a chapter. When I finish that, when I add all these up, I get this is 1 hour here because that's 6 sixths. It's hard to say. And over here, I would have 3 chapters. Our next one says Mark walked 2/3 miles in 1/5 hours. How many miles can he walk in an hour? So I'm doing miles per hour. An hour means per. I could do my drawing again if I like. Helps if I have it in screen there. I'm going to cut it up into 1, 2, 3, 4, 5 pieces. So each one of these is a fifth. And I am doing 2/3 of a mile on each one. So when I add these up, I get 5/5 of an hour, which is 1 hour. And when I add these up, I'm going to get 2, 4, 6, 8, 10. 10/3, which is 3 1/3 miles. So that's what it looks like from a model perspective if you wanted to model it out. This also explains why when we do our keep and multiply by the reciprocal, we multiply by the reciprocal. If you notice, I needed 6 of those. I needed 6 of these, correct, to figure it out, and that's why I end up when I flip it, I multiply by the reciprocal, which is 6 wholes. Same thing down here. I need 5 of these, so that's why when I would do my miles per hour, I would do 2/3 of a mile, and he can do that in 1/5 of an hour. So that is 2/3 divided by 1/5, which is 2/3 times 5/1. So there it is right there. There's my 5. That is why I do the reciprocal or the flip. And I do indeed get 10/3, which would be 3 1/3, and I could write it as miles per hour. Now, the next question says, how many hours does it take Mark to walk a mile? So I was miles over hours, and now I'm going to be hours over miles. So if you notice, like we said, we went from miles per hour. And now this question, though, is asking me about how many hours for 1 mile. So if you notice, those are reciprocals of each other. That's a flip. So if I figured out that it's that 10/3, I can take that and just flip it. So I could go all the way back to the start, and I could say 1/5 divided by 2/3. And I get 1/5 times 3/2, and I would get 3/10. Well, you notice that is the reciprocal. So if a problem asks me one way and then it changes the order that they're in, all I have to do is go back to that fraction, even if it was improper, and I can flip it. So that means that it takes 3/10 of an hour for Mark to walk 1 mile. And 3/10 obviously is much shorter. And if you want to talk about how many minutes that is, 3/10 of an hour, a tenth of an hour is 6 minutes. So 6 minutes times 3 would give me 18 minutes. So how do they relate? Well, the answers are reciprocals of each other, because we went from comparing it in one order and we just flipped the order that we were comparing them in. So that's why they are reciprocals of each other. The next one says you are running a fuel economy study to see which car can travel the greatest distance on 1 gallon of gasoline. Well, they didn't tell us to the 1 gallon of gasoline. They told us to the 4/5 and to the 1 1/4. So if I want to know how far I can travel on 1 gallon of gasoline, I'm going to be doing distance over gallons. And my distances here are in miles. So I have car A, and it's going to be miles over gallons because I want to end up with 1 gallon. So what I'm going to have here is I'm going to have 18 2/5 divided by 4/5. When I do that work, let me slide up a little bit here, I'm going to have to turn 18 2/5 divided by 4/5. I need to make this mixed number into an improper fraction. So I'm going to do 18 times 5. So 8 times 5 is 40, 10 times 5 is 50, so we should get 92 over 5. Now remember, don't change that to multiplication until you actually flip to your reciprocal here. I have a lot of kids that do this, and they do all that work, and then they're like, oh, I must have already flipped it, and so they throw that multiplication sign in, and then they never do the reciprocal of the second fraction. Now when I do the reciprocal of the second fraction, I notice right away that I can cross-reduce. Those are going to cancel out. They're both going to become 1s. So I'm going to get 92 over 4, which means 92 divided by 4. So that means that car A can go 23 miles on 1 gallon of gas. So now I need to look at car B so that I can then compare them. I want you to pause this. I want you to try car B on your own, and then I want you to turn it back on and see if you got it right. If you're still really struggling, go ahead, hit the pause, try it out, and then come back and look at it. I would go ahead and pause this and look at what I've done so far. I'm going to go ahead and show how to make sure that you know how to turn this improper fraction into a mixed number and understand where. I'm not going to get over here. I got a nice whole number. I didn't have anything left over. When I do this one here, 5 goes into 14 2 times. That gives me 10, and I have that 4 left over. So that becomes my new left over is my numerator, and I still have that same denominator. So this car is going to get 22 4/5 miles per gallon. Now it says which car is more fuel efficient. Well, which car gets more miles per gallon? So the answer is going to be car A is more fuel efficient. And that's because 23 miles is farther than 22 4/5 miles. Heading on to the back, we've got 2 more problems here that we're going to look at. We have, suppose a water pump moves 330 gallons of water in 22 minutes. How many gallons of water does the pump move in 39 minutes? This is a 2-step problem that I want to show you here. So it says how many gallons, and we're talking minutes. So gallons to minutes, and I'm moving 330 gallons in 22 minutes. Now sometimes you can get from 22 to 39 in one easy step, but we're not going to be able to do that. So we're going to get down to in 1 minute, and then we're going to go from there to 39 minutes. So to get from here to here, we are dividing both by 22. When we end up with this last part, we're going to multiply by 39. And I'm going to pause and do the work to the side, and then you can turn it back on and check. So I want you to pause and look at the work that I've shown here. So I did 330 divided by 22. I had whole numbers here and not fractions, but you can see I got 15 as my answer. And then 15 gallons in 1 minute, and then I multiplied that times 39. And check my work there. I got 585 gallons in 39 minutes. This next one right here, I want you to see if you can set it all up. I'm going to pause it, do it, and then I want you to turn it back on and look at the work. So a couple things I want you to notice there. I had to put my 90 over top of a 1. And then once I got there, then when I multiply times 2.5, I turned 2.5 into a decimal. Pause this right here. Take a look at it. Make sure that you understand how to find all of those answers. And then go back and you can ask me questions if you need any.